Okay, in this video we're going to learn about the Pythagorean Theorem. So, one ingredient you need for the Pythagorean Theorem is a right triangle. So this is a right triangle, and you can see that because right here you have a nice big, I'll make it bigger, right angle. Alright, so then we have to term the sides a certain way. So in this example, the side that's opposite the right triangle is going to be the longest side, and that side is called the hypotenuse. This A and this B are legs of the triangle. So you've already understood that in a previous section that we've studied this year. But what we're going to concentrate now is on the relationship between the sides. So if you have a right triangle, this is the relationship that holds. If you take each leg, so here's leg 1, leg 2, and you square each one individually and then add them together, that sum will be the C side squared. So let's try one. What if this was a 3, 4, 5 triangle? Establish this relationship for me, and let's make sure it works. So the side I'm calling the A side is 3, so I square that, and the side that I'm calling the B side is 4, I square that, and the side I'm calling the C side is 5, and that C side is the hypotenuse. So we're going to square that. So remember, the relationship is between the sides squared, not just the sides. So 3 squared, if you did that in your calculator or in your head, that's 9. 4 squared is 16. 5 squared is 25. So let's check. 9 plus 16 is indeed 25, so that relationship is verified. Okay, that relationship is called the Pythagorean Theorem. Now, do not worry about the legs. A better way to understand the Pythagorean Theorem is to view it as leg squared, so leg squared plus leg squared equals hypotenuse squared. Alright? And the hypotenuse is always, forever and ever, the side opposite the right triangle. Alright, so this is all from the overview page. So let's go to another section of the overview page. So here's a nice clean picture. It explains it a little bit more. It's still using the A, B, and C's. So just to make my point, it's not tied into A, B, and C. We can call this C, D, and E. If I change the letter, what's the relationship? So you should say, well, the relationship is leg squared plus leg squared equals hypotenuse squared. And that establishes the relationship. Okay, so down below we have some triples. So I'm going to talk about that next. So let's do that in the next video, or the next page of this video. Okay, on this page, we're going to talk about what I had termed triples. So these are patterns that frequently show up in Pythagorean theorems. So they made the hypotenuse side red, and they've made the leg side kind of a purple color. So it's leg squared, okay, this is a leg, that's leg squared, plus leg squared equals hypotenuse squared. Okay, another one. Leg squared, that's a leg, plus leg squared, that's a leg, equals hypotenuse squared. And the final one, make sure you see that this is the hypotenuse and these are the legs. So it's leg squared plus leg squared equals hypotenuse squared. Okay, I want to talk about this nautilus shape too in just a sec. So let's do that on the next page. Okay, I'd like you just to look at this and see what we have. So you're starting out initially with a right triangle. Here's your first right triangle. Let's see if I can make this a color we can see. So here's a leg, and here's the hypotenuse. This leg is 1. The other leg is also 1. And 1 squared plus 1 squared is 2 squared. So that hypotenuse is the square root of 2 squared. This is radical 2. So what they've done here is they've kind of built a spiral. And so they take the hypotenuse of triangle 1, and it becomes the leg of triangle 2. Okay, then the hypotenuse of triangle 2 becomes a leg of triangle 3, and so on and so on. And they're spiraling it, so you see you have a very pretty picture. So we may try that one day. Now that we have established that, and I'm going to use I'm going to change colors for one. Okay, so let's use a right triangle. Let's say that I had my leg and my other leg, but I didn't have this value, and I knew it was a right triangle. So how can you use Pythagorean theorem to find a missing value? So you would say, Pythagorean theorem tells me that 3 squared, leg squared, plus leg squared equals hypotenuse squared. And be comfortable with this being the hypotenuse because it's across from the right angle. So what's 3 squared? Well, 3 squared is 9, plus 4 squared is 16. That has to equal x squared. So if I add 9 and 16, I get 25. So 25 equals x squared. Well, I would like to know what x is. So I'm going to take the square root of each side. When you take the square root of a squared term, you get 2 answers, plus and minus x equals. So the square root of 25 is also plus and minus 5. But yeah, let me take that back a little bit. This side you get x, and the other side you get plus and minus 5. All right, so we're going to forever, when we do Pythagorean theorem, only deal with positives, because you can't have a negative length of a triangle, right? So it's only going to be positives. Those are called the principal roots. So I'm going to say that x is going to equal 5, and 5 is our hypotenuse. All right? You will never get a negative value for your hypotenuse. So we're always going to deal with what they call principal roots, which is all the positives. Okay, we have a lot more practice to do, so let's get to it. Okay, so you're going to need a calculator to do this, because it says determine the missing length in each right triangle using the Pythagorean theorem. And then it goes on to say, round the answer to the nearest tenth. Okay, so the 10th position is the first position after the decimal point. All right, so let's try the first one. So I'm going to have you not memorize c squared equals a squared plus b squared. I'm going to have you memorize leg squared plus leg squared, oops, I can't get my 2 to work, equals hypotenuse squared. Okay, that is our formula. So with that in mind, this is a leg. This is missing. I'm going to make it an x. Okay, this is the hypotenuse. So my equation is going to be 12 squared plus x squared equals 15 squared. Side squared plus side squared, or leg squared plus leg squared, equals hypotenuse squared. So the terms that are numbers I can actually square. So to square a number, you multiply it by itself. So I know that 12 times 12 is 144. Plus x squared equals, in my calculator, I would say 15 times 15, and you should be getting what? So go ahead and do it. I'm going to pause for a second. So you should have gotten 225. Okay, now, you have a one-step problem. You want to get x by itself, so you want to get x squared by itself. Subtract 144 from both sides. Okay, in the calculator, 225 minus 144 gives me 81. So I know that x squared equals 81. So take the square root of each side, square root, and I'm getting x equals 9, and that is the length of BC. All right? Okay, let's do the next one. So in this time, let me just erase some of what I have here. Okay, so I have some more space to work. All right, so I'm seeing that for this problem, I'm given a leg and a leg. So what do I know? I know that leg squared plus leg squared equals, let's make this an x squared. 5 squared is 25. 2 squared is 4. That has to equal x squared. 25 and 4 are 29. 29 equals x squared. So x, take the square root of both sides, equals radical, that's our symbol for taking the square root, 29. So in your calculator, you're going to say second square root of 29 and hit equal, and rounding it to the nearest tenth is going to give me 5.4. Okay, so 5.4 is what my answer is. My answer said in the calculator 5.38516, etc., etc. So if you want to round to the nearest tenth, here's your tenth spot. You look back. If this number is 5 or greater, the 3 goes up. The 3 went up, and I got 5.4 for an answer. All right, make sure that that makes sense to you. Okay, we'll change colors again. And looking at problem number 3 across the top, I am seeing that I have a leg, here's a leg, and a hypotenuse, and this x is going to be what I'm looking for. All right, let me get rid of that. Make it look better. Okay, that's an x. All right, so what's my equation? So leg squared plus leg squared equals hypotenuse squared. So x squared plus 36 equals 81. Our goal is to get x squared by itself. Subtract 36 from each side. And what do we get? You do it in your calculator, you should be getting 45. So therefore, x is going to equal the square root of 45. And in my calculator, second square root 45 equals, I'm going to round to the nearest tenth, and I get 6.7. Okay, so that's 3 out of the 9 problems. So I'm going to do some more, but what you should do at this point is, you've seen me do it 3 times. Why don't you turn off the video and see if you can do the next 3 problems yourself, and then turn it on and come back and see how you did. Okay, so I hope you did some practicing on your own. What you should be getting for question number 4 is, you should have said 3 squared plus 14 squared, because that's leg squared plus leg squared, equaled, make that an x squared. So continuing down below, 3 squared is 9, so 9 plus and 14 squared is 196, and that's going to equal 277. Okay, so leg squared plus leg squared equals, well, let me not do that. Let me not do it that way, because that's going to be confusing. So I'm going to erase this. Okay, so what's that equal? That's going to equal x squared. So on the left-hand side, when I add these 2 numbers together, I get 277. 277 equals x squared. Take the square root of both sides, and you end up getting, round to the nearest tenth, 16.6 equals my x. Okay? Okay, that brings us to the next one. I'll change color so you can see it a little bit easier. So this next one, I have a leg and a hypotenuse. I'm going to make this x. So I end up with, let's see, we'll do it here. 8 squared plus x squared equals 10 squared. Okay, this is 64 plus x squared equal 100. I'm going to subtract 64 from each side. I get x squared equals 36. So x will equal 6. So 6 is my answer here. Okay, let's go to the next one. And I see that I have a leg, and across from the hypotenuse is my x, and my equation is leg squared plus leg squared equals hypotenuse squared. So if I'm going to take my calculator and say 13 squared, I'm going to get 169 plus, and 17 squared equals 289, okay, and I'm running out of room, so let me not put that there. So I'm going to get rid of that, and we'll put that, let me get rid of this, we'll put that math down here. So I said 169 plus 289 equals x squared. 169 plus 289 gives me 453. So 458 equals x squared. Take the square root of both sides, and taking the square root of my answer gives me 21.4. So I'm going to put that in this box. I get x equals 21.4. All right, there are 3 more problems to do. You should stop, make sure you understood what you did so far, and then we'll do the last 3 together. Okay, changing my color. I see I have a leg and a leg, so my equation, and an x. So my equation will be 8 squared plus 16 squared equals x squared. 8 squared is 64, so 64 plus 16 squared is 256. That's going to equal my x squared. If I add those two together, on the left-hand side, I get 320 equals x squared. Take the square root of both sides, and I'm getting 17.9, I'll put it in the middle here, when I round it to the nearest tenth. Okay, 2 more left. Okay, I have a leg, I have an x, and I have a hypotenuse. So I'm going to change color. Okay, so I'm going to say x squared, that's 1 leg, plus 1 squared equals 4 squared. So I have x squared plus 1 squared equals 16. And 1 squared is just 1, so I don't really need the squared. Right? Okay, so now I have x squared, subtract 1 from each side, equals 15. Take the square root of each side, and the square root of 15 ends up being 3.9 when I round it to the nearest tenth. Okay, last one. I'll change color. I should notice that I have leg, and here the x is my hypotenuse. So leg squared plus leg squared equals hypotenuse squared. So 49 plus 121 equals x squared. add 49 plus 121, and that's going to give us 170. So I have 170 equals x squared, and take the square root of both sides, and I get 13.0 if I round to the nearest tenth. Okay, so this is 13.0. All right, so we've done 9 problems on Pythagorean theorem. So that is good, very good practice. Okay, the last page of this packet takes us back to the triangle angle bisector theorem. And here we needed occasionally to use Pythagorean theorem. So let's look at that on our next page. Okay, the first couple just deal with angles. So we know that the angle bisector theorem tells us that angles are divided in 2 equal pieces. So it says each triangle has one of its angle bisectors. Whoops, sorry. Go back. It has one of its angle bisectors drawn. So when you see this line here, that is an angle bisector. So that means angle F, which is this angle right here, is divided in 2 equal pieces. So if they tell you that angle F, or also could be called angle DFR, equals 55, then each piece has to be 55 divided by 2. So put that in your calculator. And I'm getting 27.5 degrees. Okay, so it's just half the angle, because that's what a bisector does, and then you're all set. Okay, find the measure of angle LN, of angle NXE. That's this angle right here. And I see that it has an angle bisector right here that divided it into 2 equal angles labeled 1 and 2. So if angle 1, so if this angle right here is 25 degrees, then they want to know how big is the whole angle. Well, if angle 1 is 25 degrees, then angle 2, because it's a bisector, is 25 degrees, and 25 plus 25 is 50 degrees. So again, that's pretty straightforward. We did not need the Pythagorean theorem for that. Okay, let's go on to the next 2 problems. The Pythagorean theorem is going to show up twice. Okay, so let's see what it says. Each triangle shows its 3 angle bisectors intersecting at point C. So now you have not 1 angle bisector, but you have 3. So the angle bisectors are the blue lines. All right, so I'm going to just point it out to you. These blue lines right here, those are your angle bisectors. See how they're coming out of the angle? So they're angle bisectors. So let me take off those lines because we have a very small drawing here. So they tell us that CI is 8. So you see where that perpendicular line is going? That is CI, that's 8. So I'm going to draw that a little bit bigger here. So this is CI. Okay, so then they want to know what ZI is. Well, here is the Z, and then you connect it to the C up top. And this is a right angle. So they're giving us some idea. They say that CI is 8, CZ, which is over here, is 17. They want us to find X, Pythagorean theorem. So look where the right triangle is. It's right across from the 17, which is the largest side, which that's what it should be. So what's our equation? Well, Pythagorean theorem tells us leg squared plus leg squared equals hypotenuse squared. So x squared plus 64 equals 17 squared, and 17 squared is 289. So 289 minus 64 will be 225. Okay, so I'm going to come over here. So x squared equals 225 take the square root of each side, square root, and you should get x equals 15. All right? Pythagorean theorem applied to the triangle angle bisector theorem. All right, look at the next one. Same idea. The blue lines are the angle bisectors. The red lines are perpendicular lines drawn from the center, which by the way is called the incenter, to the outside edge of the triangle. So, what do we know? If they tell us that NP is 13, that's right here, and CN is 6, which is right here, they want us to find CP, which is X. So I'm going to make this a little bit bigger and a little bit less cumbersome in there. This is 13. This is 6. We're looking for X. Okay, so they've given us two legs. Here's the right angle. Your X is your hypotenuse. Make sure you recognize that. So give me an equation. You should be saying 6 squared plus 13 squared equals X squared. 6 squared is 36. 13 squared is 169. That now equals our X squared. So 36 plus 169 is going to equal 205. So 205 equals X squared. So take the square root of both sides and round it to the nearest tenth, and you should be getting 14.3. So that's 14.3. Okay? So there we have another one. Okay, we're going to do the remaining problems on the next page. All right, looking at these two problems, they are telling us that JY, so that's here, that's 10, and CJ is 4. Okay, so CJ is where the right angle is. So that's 4. So they want us to find CY, which is X. So let's do what I've done before. Take this out. I have a 10, I have a right angle, I have a 4, I have an X. Pythagorean theorem, leg squared plus leg squared equals X squared. 16 plus 100 equals X squared. Continuing over here, 116 equals X squared. Taking the square root of both sides. So second square root of 116. I get 10.77, which rounds to 10.8 equals our X. Okay, so I think we're just going to do this, and I'll let you do the last two on your own. See if you can get those answers. I'll give you the answers. You see if you can show me the work. Okay, so this last one, I see that QJ, so QJ is down here, that's 16, and CQ, that's this red perpendicular, that's 4 right in here, and they want to find CJ, which is right here. So let's make this bigger so we can see what's going on. This is 16, this is 4, that's my right angle, that's my X. And we don't want to have a little tail here. Okay, so let's do our Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. That's the hypotenuse is across from the right angle. So 16 plus what's 16 squared? That's 256. 256 equals X squared. So 16 plus 256 equals 272. That equals X squared. Take the square root, take the square root. Second square root, 272. is going to equal 16.5 when I round to the nearest tenth. All right, so for number 7, you should get an answer of 18.0. So let's see, why is that? CJ and CX. Okay, and so you're going to get that answer. So number 17, CX will equal 18. Why is that the case? Well, those perpendicular lines that come from the in-center, which is where the angle bisectors all intersect, those perpendicular lines are all equal, and that was in our notes. So that's why if I have one of those red lines and I know its measure is 18, I know the other two red lines are also 18. Okay, this is number 7 I'm talking about. Okay, look at number 8. They give you CM, they give you CA, and they ask you to find AM, which is a leg. So you're back to Pythagorean Theorem, and we'll change the color again, for 8, so for number 8, you should be getting 10.6 for an answer. All right, so make sure you can get those two last answers, and you're all done.